We'll take a look here at the Unit 8 review sheet. Now, as I go through this sheet, I'm going to solve it the way that they are asking me to solve it. But keep in mind, all of these problems can be solved using the quadratic formula, and you should come up with the exact same answers. So these first four problems are just asking me to solve by taking the square root, which means I should be able to move everything except for the x squared to one side. So here, like number one, if we divide both sides by -4, you end up with x squared equals -14, and now I can take the square root of x squared, which is x, and I can take the square root of -14, which is, excuse me, for every time you take a square root, you got to go back and remember this, it's plus or minus that answer. Now 14 won't break down into two perfect squares. We have 7 and 2, so nothing can be pulled out. However, we can pull out that negative, so it's x equals plus or minus I root 14. Number two, we're going to subtract 6 from both sides, so we end up with n squared equals -20. And now if I take the square root of both sides, so now we have n equals, right, square root of -20. So we have plus or minus 20. I'll break down into 5 times 4, and then we have the 2 and 2. So I can pull a 2 out. There's also that negative, so I'll pull out an I, and then 5 is what is left. Number three, first thing I'm going to do is subtract 6. So I end up with 6p squared equals -120. Now divide both sides by 6. So 120 divided by 6, we end up with p squared equals -20. And now I take the square root of both sides, we end up with p equals square root of -20, and actually we just saw this. Again, as a reminder, 20 is 4 times 5, so I can go pull out the 2, you still have that negative, so you get the I, and they end up with 5 as well. Here we're going to subtract 2 from both sides, so 8m squared is 112. We can divide both sides by 8, and that'll leave me with m squared equals 14. Take the square root of m squared, that's going to be m. Take the square root of 14. 14 can't be broken down into anything, so we just got to put the plus or minus root 14. All right, 5 and 6, these are both, they're telling us to solve this by factoring, which means they are factorable. Step one is make sure we get this thing in standard form, right? Make sure we get into standard form. So that means everything to the left, or whichever way you have to go to keep that squared thing positive. Move that -6 over, turns into plus 6x minus 16. So we need factors of -16 that add up to be 6. I believe 8 and -2 will do it. So x plus 8, x minus 2. There is no bottoms up here because there's no leading coefficient, which means now I can just do the opposite of what's in there. So x is either -8 or +2. Here we have n squared, not m, minus 2n minus 35. So again, step one is to get this thing into standard form. That equals 0. And so I need factors now of -35 that add up to be -2. I think 7, -7, and +5 will do it. So n minus 7, n plus 5. Again, no leading coefficient, which means I don't have to worry about bottoms up. So it's just the opposite of what's in there. So n equals 7, and n equals -5. On the next page, again, back into standard form. So 6m squared plus 17m plus 12 equals 0. So now we do 6 times 12. So factors of 72 that add up to be 17. I believe 9 and 8 will do it. So we have m plus 9, m plus 8. Now I have the leading coefficient of 6. There is a leading coefficient, which means I need to divide my numbers by those two things. So go ahead and simplify. We end up with m. 9 and 6 both have a 3, so that can be 3 over 2. 8 and 6 both have a 2, so we can do 4 over 3. Leave yourself a little bit of space, but I know my solutions right now, before I do the bottoms up, the opposite of what's in there. So -3/2 and -4 over 3. So there's my solutions. And then just so we get the full factored form, remember, do bottoms up. So we have 2m plus 3, 3m plus 4. Number 8, let's get that 5r over, which turns into minus 5r. Minus 25 equals 0. So we need factors of 2 times 25, which is negative 50, excuse me, negative 25, that add up to be negative 5. And I think negative 10, positive 5 will do the trick. So r minus 10, r plus 5. We do have a leading coefficient, right? You have that leading coefficient of 2, which means you need to divide both of these by 2. So here it ends up being r minus 5. We can't simplify this, so we're going to end up with bottoms up. Let me take a moment. R is going to be the opposite of 5 and the opposite of 5 halves, which is negative 5 halves. And then I'll go back and I'll fill in my factor very quickly here. So we end up with 2r plus 5. So bring the bottom, whatever's left after we simplify, bring it up. So we get our full factor. Right? And then 9 and 10, they ask you to use the quadratic formula. So here's step 1. Let's make sure we have it in standard form again. Plus 8x plus 4 equals 0. So a is 7, b is 8, c is 4. So opposite b plus or minus b squared, so that's 64, minus 4 times 7 is a, times 4 is c, over 2 times a, which is 14. So now we got negative 8 plus or minus. Let the calculator kind of take over from here. I'm absolutely okay with that. That way we don't make a mistake with any negatives. So it ends up being negative 48 over 14. So 48. Let's see what we can break 48 down into. So 48, we can do 4 and 12, which will turn into 2 and 2. We have 2 and 6. We have 2 and 3, which means I can pull out 2 different 2's. So we end up with negative 8 plus or minus. So both 2's together will be a 4. You pull out an I, you have a 3 over 14. And now take a quick look. This is where you could do your heart. Right? Do all 3 of those things have something common? And sure enough, they do. They all have a 2. So divide everything by 2, negative 4 plus or minus. That'll turn into 2i root 3 over 7. Take a look at number 10. So let's get that 8k to this side, which turns it into plus 8k. A equals 12, b equals 8, c equals negative 1. So here we go, x equals opposite b, so negative 8 again, plus or minus. B squared is 64, minus 4 times 12 times negative 1, over 2 times a, which will be 24. So now we have negative 8 plus or minus square root. Let the calculator do it for us. 4 times 12. This ends up being 112 over 24. So now it's just, let's see what 112 will break down into. So 112. I get a 4 and a 28. Now this is 4 and 7. So actually, I don't have to break down the 4s. I realized real quickly I can pull a 4 out. So you have negative 8 plus or minus 4 root 7 over 24. Draw your heart. And sure enough, do all 3 of those. Again, they're all, not only are they all even, I can pull a 4 from all those. So divide everything by 4, and we end up with negative 2 plus or minus 1 root 7 over 6. So that one you can divide them all by 4. And then finally, these last 4 problems, find the discriminant. Remember the discriminant, that was just b squared minus 4ac. No square root involved. So here just label a, b is negative 10, c is 9, and just plug it in now. So the discriminant, I'm going to call that big D, equals b squared. So negative 10 squared is 100, minus 4 times 1 times 9. So that's just 100 minus 36. Discriminant is 64, which means this has, it's positive, so it has 2 real solutions. Here, a equals 2, b equals negative 8, c equals 8. So here we go again, discriminant, b squared. That'd be negative 8 squared is 64 minus 4 times 2, times 8. So 64 minus 64 is 0, which means this has one real solution. This is a double root. That'll touch the x-axis once. Here, the only trick, just get everything to one side, and I like to keep that squared term positive, so I'm actually going to move it over here. End up with 0 equals 3x squared minus x plus 2. So a equals 3, b equals negative 1, and c equals 2. So here we go, discriminant equals b squared. Negative 1 squared is 1, minus 4 times 3 times 2. So 1 minus 24 ends up being negative 23. So a negative tells you you have two imaginary solutions. So far we've seen one of each. And then let's get this last problem done. I'm going to move that 7 over first. So that'll be plus 7. So a equals 7, b equals 10, c equals 7. So the discriminant, b squared again, that's 10 squared is 100, minus 4 times 7 times 7. And when you do 4 times 7 times 7, subtract that from 100, you end up with negative 96. It's negative, which means you have two imaginary solutions.